Welcome everyone to another episode of Let's Make a Game. In today's episode I have something really special for you guys. I finally figured out a more or less satisfactory way of creating islands. Of course randomly generated, and today we shall code it together. Within the next few seconds I will showcase you the results of today's work, so hopefully you can look forward to the rest of the video. Before we continue any further, let me show you what I have set up newly. In between the episodes I have added a bunch of sprites, such as the sand tile set and the ocean tile set. So today we're gonna play around with these guys as well. I also renamed the tile generation script to world generation. I added a drawDef GUI script instead of having the script on the object. And I also did that for the draw loading bars. We're gonna use all of these scripts in today's episode, but most of all the world generation. Of course I also created the respective objects. There are no scripts on any of these objects except of course the heart, which contains all of the code, all of the scripts which are necessary for what we have so far. Okay guys, if we have a look into our world generation, or previously known as tile generation, we can see the code we have built in one of the previous episodes. We don't need this code anymore. We will be needing parts of it, so it's not gonna be in vain at all. But we want to start fresh because we want to start with a different part of the generation first before we generate all the tiles. So let's give this another title called World Generation. And we are gonna start with the island generation. So instead of generating all the tiles, we're gonna generate the island shapes first, and after that we're gonna generate all the adjacent tiles. So just like with the global tile generation equals true, we want something similar, namely the world generation equals true. So at this point we are gonna switch over to the global variables, and I will show you what I have added there. As you can see, I have sorted and titled our global variables because they accumulated a little bit. We still have the variables from the previous episodes, of course. I changed the tile count not to increase while generating, but to be calculated using the room width and height divided by the tile sizes and multiplied with each other. So just the basic mathematics here. We also still have the camera options from the previous episode, of course. But right here we have a bunch of new variables which I'm gonna explain you during the process of setting up this script. So instead of the tile generation, which we are not gonna need anymore, this is a variable which is obsolete. We now have the island generation as the first phase of the generation being true, and after that we have the world generation, which replaced the tile generation, but we get to that in just a bit. There's also a island size. This makes sure that the size of the island varies from seed to seed and from generation to generation, but I'm gonna explain that as well. We also have a tile progression variable and a stop island generation variable, which are both set to 0, and we will also be using them in our script. So right now if we add back our global tile generation true, we have not much of a generation going on, of course. And as you can see, I also changed it to the ocean tiles instead of the grass tiles being generated. But nevertheless, that's what we have so far, and that's what we are gonna change right now. Back in the world generation we are, and what a traumatic experience. I already made a mistake. This of course should be island generation. This is the first variable that is true in our global variable script. So let's close this off and we're gonna start coding. First of all, I want to place an initial grass tile. So since the room is empty, we can go for a condition such as if there is no instance exists of the object grass tile set. Then we want a few things to happen. First of all, since this is the first condition, we want to speed up our room. So let's say the room speed is gonna be, let's go with a really high number, something like 5,000. If your computer can handle it, We also want to change the view width, of course, that's what we have done down below as well, to the room width. Also, of course, the room H view of 0 equals room height. Next up, we want to place down a grass tile. So what we're gonna do is place the hard object in the center of the room. So we're gonna say X room width divided by 2 and Y room height divided by 2. So it's gonna be in the center of the room by 2. There we go. And of course we have to create the instance at X, Y, and it's gonna be object grass tile set. Okay, and with that we have initiated the actual island generation. So now logically we are gonna start coding the secondary grass tiles. For that we have to set up quite a bunch of conditions, but first and foremost we want to check if there is an instance of the object grass tile already, and if that is the case we want to check for a bunch of directions. So let me explain you that briefly. If we have a look inside the room, I might be able to explain you a little bit easier what I mean. So let's say this is the initial grass tile that we place. What I want to do now is check for all of the adjacent tiles whether or not there is already a grass tile, and if there is not, I want to place one. I also want to place one here, 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 and here. So this is kind of going to be my brush size. So each frame I want to check for all of these tiles, and if there is no grass tile, I want to place one. After that, we want to change the location of our hard object to a random position, maybe for instance here, and then we want to check for the closest grass tile, which would be this one right here, and then we want to change the location again, so it's going to go right here, then it's gonna brush again the same thing just like that, and it's gonna go to a random position again, back to the closest one and brush again, and this way we are going to create an island. Again, while coding, mistakes happen. I of course made a thinking mistake. I said it correctly, but I wrote it wrongly. It is H view of 0. Let's continue with the tile checking. We want to check the right direction first. If there is no instance of X, Y, object, grass tile set. Let's see, we're gonna need this a lot. We're just gonna copy it a bunch of times. So this is gonna be the down direction. Then we are going to have the left one. This is going to be the up direction. Now we're gonna have right down. We have left up, right up, left down. So these would be all the directions for the adjacent tiles. Now we have to check for the tiles which are 2 tiles away. So that would be right 2 times, then down 2 times, then left 2 times, and finally up 2 times. Yeah, so these should be all the directions, and now of course we will have to adjust the X and Y positions respectively. So right would be plus global dot tile size, and now I think it would be wise to actually copy this. Down would be Y plus global tile size, left is X minus, up is Y minus, right down is X plus, Y plus, left up would be minus minus, right up would be plus and minus, then we got left down, which is minus plus. Then we got right 2 times, which would be plus 2 times. Down 2 times, Y plus 2 times global dot tile size. Left would be minus 2 times. And finally up 2 times, Y minus 2 times global dot tile size. Perfect. Gotta love copy and paste. Another very important thing I want to implement right away is the restriction of creating grass tiles right adjacent to the edge of the room. I want to have at least 1 tile of ocean before any island starts, so we shall implement that right away with an AND condition. So for instance, for this one we're gonna say, and if X plus global dot tile size is smaller than the room width minus global tile size. So this will basically make sure that we cannot place grass tiles further to the right than -1 global tile size from the room width. It should be pretty clear, I think. So let's also make sure that we have this formatted correctly. And we're going to do the same thing down below. Unfortunately, we cannot just blindly copy it over. For instance, this one right here would be y plus global dot tile size is smaller than room height minus global dot tile size. So this is pretty similar to the upper one, except of course we're checking for the y coordinates. Then down below here, this one is actually pretty easy. Here we only have to check if the x minus global dot tile size should be bigger than 0. And this will make sure that we don't place grass on the left side of the room. We're gonna have at least one tile of ocean. Well, now we basically have to do this for all. So the upper direction would be y global tile size is bigger than 0. Okay, so we've done the easy directions. Now, of course, for the two-way directions, we're gonna also have to make 2 additional statements. So now we can actually start copy over stuff. For instance, right here we are going to need this statement. So I actually see the pattern. This is pretty easy. We can just check if we have an addition or a subtraction going on. For instance, right here, this y plus, we have the same thing right here. So we can copy this over and paste it down below here. And then we have x minus and y minus. X minus we have right here. So we're gonna copy this over. We're also gonna need the y minus, which is this one, and add it right here. Yeah, and so on and so forth. So let me add all of the conditions to the various directions just like that, just by copying and pasting, and I'll be right back. To finish off this segment of the code, we of course want to put something into these if conditions, which is going to be an instance create of a grass tile set. So what we can actually do is delete whatever we have in the brackets and just copy this over for each of the statements. Paste in here, paste in there, and so on and so forth. And all we have to do now is take whatever we have in the brackets up here and paste them down below. So that is actually a really easy process. But as long as we can take advantage of such things, we shall. So there we go, everything is done. Okay, remember, this all happens within one frame. So what we want to do now is add a random attribute to the process which moves the object heart around before it redoes this process up here. So let's just go down here a little bit and call this relocate, why not? And we're gonna use the function move random. For both the H and V snap, we're gonna use the global tile size, of course, and this will basically place our object heart in a random tile in our room, which is exactly what we want. But if we test the game right now, we would be getting weird effects, of course, because we get all the shattered islands, and that's not necessarily something we want. We want to do something entirely different. So what we want to do is to move our object heart after it has been relocated randomly to the closest grass tile which still exists. So we're gonna say the move to variable is instance nearest of the current position of the heart, and we're gonna check for the object grass tile set. Next we need to move the x to the move to x and the y to the move to y, and we should be at the nearest grass tile set. Great, so if we test the game right away again, we will be getting much better results. As you can see, an island is kind of forming, stretching out. It's still a little bit fractal. What we could do is increase the brush size, but of course that would mean a little bit of work. But we could add that easily at a later point. But for right now, I'm really happy with the generation. One thing, of course, we will have to do is to actually limit it. So let's take on the limitation maybe right here. We're gonna call this generation limits. And for that we're gonna use one of the global variables I told you about before, namely the stop island generation. We want to set the stop island generation plus equal 1. So each step we're adding 1 to the stop island generation, which we have generated in the global's variable script. Next up, we want to check if the global stop island generation has reached a certain level. So we're gonna set that to equal global.tilecount, which is the total amount of tiles, which varies depending on the world size, and we're gonna divide that through global.island size. And if you remember, the global island size is actually a random number chosen between 5, 10, 20, 25, 50 and 100, and those are just the numbers that actually do work with this calculation. So now if that condition is actually true, we want to set the x position to 0 and the y position to 0 again, because here we prepare it for the actual world generation. So we're gonna also set the global world generation to true, and we're gonna set the global island generation to false, just like that. The beauty about this process is that we can actually generate islands which have different sizes. So let me just demonstrate that. I have bound a key so that I can reset the world at any time. So for instance, now we have a very large island seed, but if I reset that, we might get a smaller island seed such as this one or this one, and so on and so forth. And they are being generated quite quickly because we have set the room speed to 5000. Heck yeah, so this is pretty great, I have to say. Also, another thing that is very nice is that the islands will adapt to the room size. So for instance, if we doubled the room size, we would still get a proper generation. Let me just demonstrate that. So here we go, we have a much larger island, of course, because we have a much larger room, and if we regenerate that, it will basically do the same thing as it did on the small one, of course on a larger scale. Now these islands are really fractal, but it will improve slightly once we actually add the sand layer. So I think we should get to the next part of the generation. Okay guys, we are ready to continue with our world generation script. This time it's really gonna be about the world generation, or at least that's what we're gonna call it. Of course we need to start with the if global.world generation equals true. Only then stuff should happen right here. First of all, we want to kind of initiate the same process we did right here, so we can probably just blindly copy over stuff, but I think I'm just gonna do it freshly. First of all, we want to add a global.tilesize to the x position. Next, we want to check if we have reached the room width. So if x equals room width, then we want x to be 0 again, and we want y to be plus equals global.tilesize. So we're gonna go one tile to the right until we have reached the end of the room and get back to the next row. That's probably all we had to do for this one, so let's give this a title. This is going to be check all tiles, and then we're gonna have a different function which is gonna be the finisher. So everything we write in here will happen as soon as everything has been generated. So that is the if y equals the room height, then we want x to be 0 and y to be 0. We want the room speed to go back to 50, and we want the global.world generation to equal false. That should be good. Okay, two more things I want to actually add here is, first of all, right here we want to change a global variable called tile progression, and we want to set that plus equals 1. Every time we check a tile, we're going to add 1 to the tile progression. In the end, as soon as the tile progression equals the total tile count, we know that the generation has been done. Another thing we are already going to prepare right here, though we're just going to put it into comments, is the view width of 0 should equal view width, and the view height or h view of 0 should equal global view height. There we go, and this will make sure that after the generation we go back to our normal resolution, but for now we just want to keep it so that we can see the whole room before we change that. Okay, so now within our world generation, within the if global world generation equals true statement, we want to add yet something else. else, namely the ocean generation. So now basically for each thing we want to generate, we can add a section in this document. So this is going to be really overview-ish. Anyways, in order to generate the ocean, we want to first check if there is a grass tile set or not. So if an instance doesn't exist on the XY object grass tile set, then we would like something to happen, and namely that is instance create XY object ocean tile set. So that basically means whenever there is no grass tile, we want to create an ocean tile. But of course this will not be the only condition to check for. We want to add a bunch of AND statements, namely if an instance doesn't exist on the X plus global.tilesize Y object grass tile set like this. So we are also checking the adjacent tiles, because as soon as there are adjacent grass tiles we want it to be sand and not ocean anymore. So we're gonna check for each direction individually and make sure that there is no grass tile set in the immediate vicinity. So let me just make the general statement object grass tile set, and after that we should be able to just, copy this over for each direction. We'd have to make the Y here plus global tile size, then here we want the X minus, then here we want Y minus, X plus plus, then X minus, Y minus, then we have the plus minus version and the minus plus version. So let's make sure we are actually adding the global tile size everywhere. Okay, perfect. So with this code now, only tiles which have no adjacent tiles around them should be able to produce an ocean tile. Let's actually see if that worked. Okay, here we are in the game, and it is fascinating, of course. Right now, no matter how large our island is, the ocean gets generated perfectly around it, I have to say. Even in areas where it's more of a lake than the actual ocean. So if we have enough space, it will also produce the ocean tiles right here. That means we only have to take care of that all of the other tiles are being filled with a sand tile. So that will be the next goal in the code. Okay, so let's continue with the sand generation. We're gonna make a new title so that we find it easily again. Here we basically have to do the same thing as before. We want to check for all adjacent tiles, but we will have to actually add additional statements. But first of all, we can, I believe, just copy this over. We don't want to check for the tile where we are on at the moment, so we have to change this into the if statement. There we go. So these are the 1, 2, 3, 4, 5, 6, 7, 8 directions which are possible. And here we have to add the condition that there is no instance already of the XY object grass tile set, because of course it is also possible to have the conditions for sand going on while there is already grass placed, and that's one thing we don't want to happen. So we're just gonna copy this and we're gonna add this for each of the statement, just as an additional condition. You're gonna check everywhere around yourself, but also the tile you are standing on right now. Place that in here, and of course we don't want to create an ocean tile set. In this case we want to create a sand tile set. There we go, great. I believe that's basically everything we had to do. Let's check in-game once again. Of course there's a rookie mistake I made. We want to check if there is an instance and not if there is no instance. So we're gonna have to remove all of these exclamation marks, but we're gonna keep these. So these conditions are right, and now we have corrected those as well. Sometimes an additional mistake I made is that we want to check for each condition individually. So either these two conditions are true, or these two, or the next two, and so on and so forth. So what we have to do is exchange each of these AND conditions with an OR condition, so it will check for each line individually. Okay, so the last generation type we currently have is the tree generation. This one we're just gonna keep really simple for the time being. We're just gonna check if there is an instance already of the object grass tile set, and also if there is no instance of the tree already there. In this case, we want to check for a random tree variable, which is going to be random 100. We have done this previously. I'm going to say if rand tree equals, or let's say is smaller than 10, then we want to create an instance of the XY object trees. There we go. So let's get back into game and see how that feels so far. Okay, so from the looks of it, everything is generating more or less in the way I want it to. It is also pretty fast at a very low room size. So right now we only have 3200 by 3200, but this speed that we have going on will actually change once we apply it to a bigger room. Okay, so to finish off this video, we want to do some optimization starting with the dev GUI. In here we want to add a bunch more of those statements. So let's see, we want to draw the text on the y coordinate 40, and this should be ocean. So this will show me all the ocean tiles, and for that we're actually going to do an instance number, and you can put in an instance name right here, which is of course the ocean tile set. And this will basically count all the visible and active ocean tile sets at the moment. We only have to rinse and repeat this for all of our different tile sets. So right here would be sand, grass, the trees. Let's also make sure this is 60, 80 and 100. And we have to change this to sand, this one to grass and this one to trees. Great, that's all we had to do for this window. Next up, we're gonna have a look into our draw loading bars. We need to adapt the document here too. You can see that I have removed everything so that we can start freshly with our load percentage variable, which is 100% divided through the global tile count times the global stop island generation, if you remembered. And after that we also need to make sure to actually multiply this by the global island size so that it will adapt depending on the room width and height. We also want to add another load percentage, and we also want to correct that mistake. We're gonna call this percentage 2. This one here we also want to set 100% divided by global tile count multiplied with global tile progression. The tile progression, if you remember, is also set to 0 at the beginning of the room. Anyways, now we can start drawing our text. If the global.island generation equals true, then we want to display a health bar x1, y1, x2, y2 positions with the load percentage, C gray as a background, C red as a min color, C green as the max color, 0, true. Just the same thing as we did in the previous episode. We're also gonna draw a text on x1, y1 called generating island shape. And we're gonna draw a text on x1, y1 plus 20, so it's beneath the text, and that's gonna be, of course, the load percentage. Great, now we can just copy this over and add the same thing for the world generation. So we're gonna add a secondary loading bar, load percentage 2 and load percentage 2. That's all we had to do for this document. Well, there we go, guys. We have our room, we have our island generation, the loading bars are working. I had to change the generating world text so that it doesn't show the generate island shape text, but you can see that it basically is working the way we intended it to be. Now, of course, if we apply this script to a very large room, this will take forever to generate, and this is what we are going to optimize in the beginning of the next episode. There's just a few lines of code we have to add in order to also make it smooth and nice and very fast for larger worlds. But I think this video has been long enough already, so thank you very much for watching. I hope you enjoyed it. Don't forget to leave your likes and suggestions down below. Have a great time, and hopefully I'm gonna catch you the next time.